Hey mini enthusiasts, how are you doing? Welcome back. It's part 6 of the project kit build. I thought I'd try something a little bit different this time and try and narrate my way through the time lapse, just so it gives you guys a bit more information, and see what you think of it. Let me know, drop a comment down the bottom if you like it or don't like it. I'll try and overlay some bit of music in the background maybe to make it a bit more interesting. But yeah, the idea with narrating it is just to give you guys a bit more of an idea. So I think if you remember from part 5 of Project Kit, I mentioned that we'd run out of gas. So what you can see going on here at the moment is me seam welding the floor pan of the M machine, complete sort of sills, inner, outer sills, and the sort of first third of the floor plan. So I'm going along here seam welding. Not too happy with the welder running on the small bottle gas, which is like the hobbyist gas you get from Halfords. It doesn't seem to weld as well, and I think that's due to the make-up of the gas inside the bottle, and it's at a lower pressure as well. So the little hobby bottles I think run at about 60 bar, and the sort of bigger medium-sized bottles that we have been using for welding they start at 200 bar. Obviously you're not getting that much pressure out the tip of the welder, but it does allow you to, or it will run a consistent pressure right down until the big bottle's empty. Whereas these little bottles, I think once they start running low on gas, I could certainly notice that the pressure was changing on the outlet of the nozzle. The other big difference I think is the big bottles, from memory, we were getting argon mix, which I think was 95% argon and 5% CO. So I kind of got used to welding with that. It worked really well. We changed over to the Halfords bottles, which, like I said, are extremely expensive in comparison, and they're only 80% argon and 20% CO, so you just don't get as good a weld. It's more splattery, it's a colder weld, and it's not as consistent, so wouldn't recommend them at all. And they're a hell of a lot more expensive when you work it out. And also, because they're only 80% argon, 20% CO, CO2 is very cheap. So a higher concentration of CO, lesser concentration of argon. So yeah, you're buying cheap, or you're buying expensive, and you're getting a really cheap gas. So as you can see here, I seam welded the whole floor. What I had to do was go back on the inside, because generally when I weld the floor or two panels like that together, it's a seam weld with a kind of 1mm gap in the middle, and I filled the gap with weld. And generally my own sort of standards is I like to see good penetration on the front and back of the weld. Obviously you can't always do that if it's a closed box section, but something like the floor and a sill, you can go inside and have a look what the sill's like. So you can see here actually Mark's going through, looking at the welds, shining a light on it, and I can see inside whether there's any small pinholes in it or anything like that, and then go along and just make sure the welds are spot on. So when they're good, when you look at them, the penetration of weld looks pretty much 50-50. You get the same sort of mound or puddle of weld inside as you do outside. But certainly I was having troubles using the Halfords mini link bottles, that it just wasn't giving good enough penetration, so I had to just go inside. Wasn't a great deal, probably about sort of 3 or 4 inches of weld, and just run a bit of weld on the inside to make sure we got penetration. So now we've got the sill welded all the way along the seam of the floor. Mark's playing around with the heel board here, just trying to line the heel board up, and we had some problems there, which we'll go into in a moment actually. But the idea was we took the measurements of the old subframe. We done the near side sill and heel board. We used about sort of 3 or 4 datum points on there, sort of known reference points on the existing shell to line everything up with. and then when we come to doing it on the offside, it just wasn't lining up as well. So you can see me there wheeling the old subframe from outside, which was completely and utterly wrecked. It didn't look too bad on film, but someone had just plated the subframe probably a couple of times actually, and they just welded, you know, a rusty bit of metal over another rusty bit of metal. So rather than use the whole subframe, because we're not quite sure whether that frame was twisted or not, the strongest part of the rear subframe is kind of where it mounts to the rear hill board. So you can see here I'm stripping down the subframe, and what we're going to do in a moment is just run a cutter through that, just separate out the rear hill board part, and you use that rear hill board to as an alignment tool for fitting back on the car. As I say, the reason we haven't used the whole subframe is because the rear of that subframe was really poor anyway. So, and with hindsight, I think what we're going to do now, Mark's got a new subframe, we're going to get that built up, and before we finally sort of weld that hill board back into place, we're going to fit the fully built up subframe back in the car. So I'll leave you with you for a moment. I'll be back in a moment, but we're just literally just cutting up that subframe at the moment, just getting it ready to bolt onto the car. I do apologise guys, just listened back to the first part of the narration and I sound pretty awful, so I'm not sure whether that's the microphone, the settings or anything like that, but I do have a pretty stinking cold at the moment, so I'll assume it's that. I do apologise. Yeah, I'll try my best to get better for you. As you can see here, we've got that rear part of the subframe off now, and we're just then bolting it in place. So doing it this way, we can absolutely guarantee that the width between the subframe mounting holes on the rear heel boards, which are welded to the sills, is spot on. What we can't be sure of is the sort of parallel alignment of the subframe, so it could be sticking out more one side than the other. So ideally you want to use a whole subframe to do that. The sort of vertical mounting sort of vertical angle of the rear heel board, well, that's pretty much determined. You can probably use a right angle on the floor plan to use that, although again, if you're mounting up a complete subframe, that's probably the best way to do it, but it's just a little bit awkward. When there's two of you, it's probably not too bad. So what we actually found here, so we started measuring it up. You can see lots of head scratching going on at the moment because Mark works in the building trade and is a carpenter by trade, and as you can imagine, he doesn't measure once, twice, he measures everything 3 times. You know, probably better than I am at that sort of thing. Very careful about what he does. So we'd taken some data points, we had some areas to measure from, and when it come up to looking at that, where that rear heel board sat, it was basically 4mm out, which was quite odd because it was 4mm out on the fully assembled end machine sill. So everything else lined up fine, but where the heel board mounting bolts lined up, it was about, there was a 4mm gap between the end of the heel board and sort of the end of the sill. Now I assume they build those things up on jigs, but obviously being fortunate enough to have both sides, we could compare the measurements one side to the other, and as you might have guessed, when we looked at the near side sill, that was exactly 4mm out from the offside sill. So there's something wrong with how that sill was made up, and you looked at it and it just didn't look right. You could see a bow in the rear part of the outer sill, and it was the width of the metal was physically 4mm thinner. So I don't know what went on there. You'd have seen Mark take some photos, and I think he was going to send them off to M Machine. And really a difficult decision to make now, because the floor's seam welded in there. Do we cut the whole lot out again and get a new M Machine panel? Or I think the fix for it was we just drilled the spot welds out on the outer sill, and from about the cross member part, and just moved it up 4mm. And what we'll do is we'll just weld that back in place with plug welds, but we moved it up 4mm and it looked absolutely spot on then. You could see with your eye that something wasn't right, so I don't know what's happened there, but it was a relatively easy fix to do, albeit maybe another sort of half an hour, 45 minutes. But unfortunately, and I think I've said in previous videos, these M Machine panels, they really are fantastic. I think they're really, really good, but maybe worth just double checking the measurements before you start, before you get too far. As I say, pretty sure that complete sill assembly was 4mm out when comparing one side to the other. Okay, so I think the best thing is if I drop a couple of photos in here, it'll probably explain a little bit better, or you'll be able to see a little bit better about what the issue was with the sill assemblies. So looking here, if you look at the black line, that was where the outer sill was originally welded. The gap looks a bit bigger on the photos, but by the end of the sill it was sort of 4mm out to bring it to the right width to get the heel board to fit correctly. And then if you're looking down the line of the outer sill here, if you look at, in particular, at the flutes themselves, you'll see the flutes at the front of the sill are much deeper than the flutes at the rear of the sill. So the actual floor pan measurements, where it was welded along the floor plan, were all correct. We double checked that. If you look at the weld line, actually the weld line does look like it curves around a bit, but that's both on the same on both sides. But as far as I'm aware, correct me if I'm wrong, apart from being a mirror image of each other, the sort of outer sills on minis are exactly the same, near side to offside. They're just a mirror image. The actual flutes themselves shouldn't narrow in towards the back like that. So yeah, I don't know what the issue was there, but like I say, it was relatively easy to fix. Just required drilling out those spot welds and moving it 4mm, which in the pictures it looked much bigger than that, but it wasn't that big in reality. So from kind of this point on, we're still fiddling around with the hill. Mark's still looking at the hill board at the back there. Really just double checking everything, making sure we weren't wrong and that the seal's wrong. I've just started on the inner wing at the front there, just drilling out the spot welds, basically where that hinge panel goes. It wasn't that rotten, but Mark's bought a complete replacement sort of repair panel, so we're just going to do the whole lot. I did get asked in some previous videos about how you weld in the strengthening bracket for the hinge panel bolts at the back there, and with the rear quarter panel on, actually I'm not sure how you would do it. As you can see on both sides on KITT when we've done it, we've cut out a section on the rear quarter panel, the rear wheel arch. It allows you access through to be able to sort of plug weld that hinge panel nut repair section, which I'll drop a couple of photos in here. And I'm really not sure how you do that with that rear quarter panel on completely, actually, without cutting it. So yeah, I don't know. Let me know if anyone's done that. Yeah, let me know how you did it, because I'm just not sure how you get access. So we're getting to the end of this video now. We've just rolled the jig back round. I was getting a bit carried away with the hinge panel on the front there. Mark reminded me that we probably want to leave a bit of strength in the shell, and we haven't spot welded along the step, the inner door step yet. So this is where we get out. Probably my favourite tool for doing mini repairs, actually, is spot welder. Worth every penny. Quite expensive to buy, but when you've got one, they work really, really well. Quick, easy, give a professional finish. The only thing I would say is you need to get them set up right, and you need to get the tips cleaned, and you need to cut the tips to the right profile. You can buy a tool to do that, but it's about 100 quid, I think it was. But it's worth buying because it gives you almost perfect spot welds then. You have to be careful when you're spot welding as well, because if you don't make a good spot weld, I think they call them fusion welds, you can go along, you can tack it on the whole way long, and it will be really weak with no sort of integrity. So it's worth playing around with to begin with on a few sheets of metal, just to check it, make sure it's set up right, and make sure you get your spot welds perfect. More than sort of MIG welding, actually, you have to make sure the metal is absolutely spotless, both surfaces, inside, outside, that you're spot welded together, because any oil, grease, contamination or paint on there will affect the strength of the spot weld. So a bit more prep required when spot welding, a bit more prep than sort of MIG welding, and obviously a lot more than gas, but worth it in the long run. You spend the prep time getting it right, and then when it comes to spot welding it, you can just buzz along the panel really, really quickly. I think the only problems you have, especially on a mini, is trying to get into some areas with a spot welder. So as you can see here, I'm going along the inner step, actually, where the door seal goes, and obviously planned all along to put the strengthening bar at exactly the right height so we could still get the spot welder in there. I didn't actually, but it turned out just like that anyway. So we managed to spot weld the inner and outer lips on this side of the sill, and then in a moment I think we just buzz on round to the other side and spot weld the other side as well, and I think I've got some close-up footage of that we'll show in a moment. But for this week, that's almost it now. In this episode, this was just the week before Christmas, so we take the Mini off the jig and send the Mini off to be sandblasted and primed, actually. Decision Mark only took a few days ago, but just to save myself prep time with the paintwork, really. So we've made the chassis strong now, and we're just sending the shell off to be shot blasted and primed now. And as you can see, this is going along, doing a bit of spot welding. So thanks for tuning in this week, guys. I've got some more footage ready to go. I'll try and get that uploaded for the weekend, hopefully. Catch you soon. Cheers. Bye.